Hi folks, this is question 3. We're told that a parallelogram exists here, ABCD, where AB is 10. Let's just draw this. It's not very good drawing of it, but so let that be A, B, C and D. So AB is 10, BC is 13, that makes this into 13. And then ABC, so A to B to C is 110, so 110. And then it'll be the same all the way around, so DC would be 10 and AD would be 13 as well. And you know that ADC is 110. I'll write them in actually. What we need to see here then is that if you cut it in half, it just makes it into two triangles. And we have a few formulas for area of a triangle. The one we're going to use is a half AB sine C. So that works well here when you've got, it works when you've got two sides and then an angle in between in a triangle. Now we're going to end up multiplying that by 2 altogether because there's two of them, because that only finds out the area of this one, but then if you multiply by 2 it finds out the area of the whole thing. So all it's going to be is just going to be AB sine C. The A and B are the two sides, the 10 and the 13. And the sine of the angle is 110. And then we're just using calculator. And we get 122 in the end. And that's part A. Right here then, we're just solving this. So I'm going to bring the cos across the equal sign. So then cos inverse of root 3 over 2. That will give me 30. That's the reference angle 30. Now be careful because there's going to be more angles, obviously, well it says that anyway. But it's between 0 and 360 are all of the angles. Right, we have to understand this CAST thing. This means that so cos is positive in that quadrant there, tan is positive in that, sin is negative in that. They're all negative in the first quadrant up there, and then they're negative in the places that they're not positive, obviously. Right, so in this case cos was a positive thing, it was positive root 3 over 2. Therefore cos is going to be positive in this quadrant down here, and this the first quadrant because they're all positive in that one. So it's going to make those two angles there. The first one would just be 30, like we have there. The second one would be this angle here. It would be from here all the way around to here. That would have to be 360, take away the 30 just because you're taking away that little bit in there. So therefore 2x is equal to 330. That's the other one. If I find out what x is, then it's just going to be x is equal to 15 for that one, and then x is equal to half of 330. That'd be 165. That's two of our answers. Now what we've to realize is that you're gonna multiply both of them by 360 times n, where n is just any number. So because what we have to realize is that we could do, if we do a full rotation, that gives us another answer. So I'm going to go back to 2x is equal to 30 plus 360, and 2x is equal to 330 plus 360. Therefore, if you add them together, you get 390, and then divide that by 2, you get x is equal to 195. And the same with the other one, then you'll get x is equal to, if you divide 2 and if you add them together and divide by 2, you get 345. So I've got 4 answers there. 195, 345, then 15 and 165. So all those solutions will work. They're all in between 0 and 360 like we had up there. And we're done then. You could try and do 2x is equal to 30 plus 360 times 2, and 2x is equal to 330 plus 360 times 2, but you won't get more values that are in between 0 and 360. Right, part C, we've got a triangle here again. So I'm labeling them M, K and L. MK is 15 root 3. ML is 45. And KLM is 25. We're trying to work out LKM. LKM is this one down here, so we'll let that be theta. And this is just going to be using the sine rule. If you take any side there, take the 45 first, so 45 and divide it by sin of the angle, so sin of the angle across from it. The angle across from it is theta, and let that be equal to another side, so we'll take the 15 root 3 and divide that by sin of the angle across from it, that's 25. And that's how we set up our equation, and now we can just solve for theta. I'm going to cross multiply, so 45 sin 25. 45 times the sin of 25 is equal to 15 root 3 times sin theta. Then if I bring the 15 root 3 across, so we get 45 sin of 25 all over 15 root 3. That's equal to sin of theta. And you could simplify that on the left hand side if you want first, or you can just do sin inverse of all of that, and hopefully it'll go into your calculator for you. Might need brackets around the 45. And that should give us an answer for theta then. We get 47 when it's rounded to the nearest degree. Now again we have to figure out, so remember CAST, so they want two values in between 0 and 180 here. So in between 180, so that quadrant, but then this quadrant is from 0 to 180, and that is positive for sin. Therefore, it's going to be this angle here, so it's the angle from here to there, and this angle in here is 47. Therefore, if I do 180, take 47. It should give me 133. That's our value then. That's all in for that question.